All right, today we're jumping into one of the biggest buzzwords in the tech world, microservices. We're going to break down what they are, why they matter, and how they work. Let's get into it.
So have you ever noticed this? You've got one app on your phone, and it feels like every week there's a cool new feature, a slick new design. And then there's that other app that hasn't changed since you downloaded it years ago. Why is that?
Well, you might be surprised to learn it often has nothing to do with the company's size or how many developers they have. No, it's all about the blueprint. And for a long time, the standard way to build software was to just build one giant thing.
To really appreciate why a new approach like microservices even exists, we first have to understand the old way of doing things and all the headaches that came with it. We're talking about the monolithic architecture.
A monolith is, well, it's exactly what it sounds like. One single, massive block of code. Think of it like a giant factory. Every single part of the business, taking orders, handling payments, managing inventory, sending emails, it's all under one roof, connected by this incredibly complex web of machinery. Everything is tangled together.
And this is where the problems start to creep in. Let's say you're having a big sale and you need to handle way more payments. Well, with a monolith, you can't just beef up the payment part. You have to scale the entire factory. It's super inefficient. Or what if you want to change one tiny feature? You risk bringing the whole system crashing down. It just leads to this cycle of fear, which means slower development. You're basically stuck. So, if that giant tangled monolith is the problem, what's the solution? Well, this is where our hero enters the story, microservice architecture.
And this right here, this is the fundamental mind shift. Instead of one giant e-commerce app, we break it apart into a bunch of small, independent services. Each one has exactly one job. The order service just handles orders. The payment service just handles payments. We've replaced that one giant clunky factory with a modern business park full of small, specialized, expert workshops.
And this gets to the why. This is why people go through the trouble. Because each service is its own little world. You can update one without touching the others. If the payment service is getting hammered with traffic, you just give it more power. If the notification service happens to break, oh well, the rest of the app keeps on running just fine. It's all about resilience and the freedom to move fast.
Okay, but this raises a huge question, right? How do you decide where to cut? You can't just take a saw to your big application and chop it up randomly. There's a philosophy behind it, and it's called domain-driven design.
Domain-driven design, or DDD for short, is a really simple idea at its core. It says, stop thinking about technology first. Stop thinking about database layers or UI layers. Instead, look at your actual business. What does it do? Well, it handles payments. It deals with shipping. It creates orders. Those real-world things, those are your domains.
And here it is, the golden rule that makes it all click. Each one of those business domains we just talked about gets its own dedicated microservice. That's it. Payments gets a payment service. Shipping gets a shipping service. The technology starts to mirror the reality of the business, and that makes everything so much easier to reason about.
So let's see how this works. The order service becomes the world's leading expert on orders. It knows all the rules, all the logic, and this is the most important part. It has its own private database. The payment service, on the other hand, knows absolutely nothing about orders, and it shouldn't. It's the expert on payments with its own logic and its own separate database. This strict separation is what keeps them truly independent.
Okay, great. So we have all these little independent workshops, each minding its own business. But for the app to actually do anything useful, they have to work together somehow. How does the payment service even know that an order was placed? This brings us to the art of communication.
Now, you could have them call each other directly, but that just creates a fragile chain. If the order service calls the payment service and the payment service is down, the whole thing breaks. A much better way is through messaging. Instead of talking to each other, services just shout out messages or events into a shared space. Then any other service that's interested can listen for those messages. It's like a public announcement system.
So let's follow an order through this kind of system. First, the order service does its job and creates an order. Then, it publishes a message saying, hey everyone, order 123 was just created. It doesn't know who's listening, and it doesn't care. The payment service hears that message and goes, oh, an order. I'll go process the payment. At the same time, the inventory service hears it and says, got it, I'll reserve the stock. And the notification service hears it and sends the confirmation email. See? They all reacted to the same event without ever being directly connected. It's beautiful.
And when we say event or message, we're not talking about some kind of magic. It's really just a simple little packet of data, just like this piece of JSON you see here. It just has the bare minimum information needed for other services to know what happened and decide if they need to do something about it.
Now, after hearing all of this, you might be thinking, microservices are incredible. Every single app should be built this way from now on. But like any really powerful tool, they're definitely not the right solution for every single job.
So what's the verdict? When should you use them? Well, microservices really start to shine when your business is complex, and you have large teams that need to work on different parts of the system without stepping on each other's toes. But there's a catch. You have to have your technical house in order. We're talking about automation, monitoring, the whole DevOps shebang. If your app is pretty simple or your team is small, all that extra complexity can actually slow you down.
So what do you do if you're not a giant company? Is there a middle ground? Yes, there absolutely is, and it's a fantastic pattern called the modular monolith. Think of it as getting the best of both worlds. It's still one single application, but on the inside, it's organized into clean, separate modules that follow those exact same business boundaries. You get all the organizational benefits without the operational nightmare of managing dozens of services.
And this brings us to probably the single most important piece of wisdom in this entire space. For most teams, the smartest path isn't to dive headfirst into microservices. The best path is to start with a really well-organized modular monolith. Then, later, if and when one of those modules needs to scale or change on its own, you can just break it off into its own microservice. You evolve into the complexity, you don't start with it.
So, the next time you use your favorite app and a cool new feature just appears out of nowhere, you'll know what might be happening behind the scenes. And you can ask yourself, am I using one giant clunky machine, or am I interacting with a whole universe of tiny, specialized machines, all working together in perfect harmony?